Welcome to the last after lunch session. I know there was another after lunch session, but I've actually got the hardest session. Sorry, Seth, because this has been 2 lunch periods in a row. So this is a talk called Sustainable System Testing with Chaos. Other people use the term chaos engineering, resilience testing, lots of different ways in order to say the same thing. My name is Paul Stack. You can find me on Twitter and some places on the internet at Stack72. If you have any questions about this session or feedback about this session that you thought maybe is a bit controversial, please let me know. Please get in contact. I am more than happy to speak to people about this. I work at a company called Samsung Research. Anyone heard of Samsung? They're a little small company that sort of makes some pieces of infrastructure for people to use. And I work in a branch of it called Joyent. So I'm working on a new cloud platform in that area. So, hands up, distributed engineers. Okay. Distributed programming is the new thing, okay? It's effectively the breakdown of systems into smaller components that are interconnected and talk to each other in a manner of different ways. Now, distributed engineering has made our lives a lot more difficult, okay? So we have so many moving parts. We have disconnected, we have remote teams, we have people writing in different languages, we have different protocols between the systems. Life is a lot more difficult than it used to be with your monolithic application. A very interesting story about how people have changed to distributed programming or distributed systems. I worked at a company called OpenTable maybe 4 or 5 years ago, and we had a change of CTO, and he came in and he said, let's break this monolithic application apart. And at the end of the 2 years, we had 14 different pieces of the system written in 4 different languages. After another 2 years, it was split apart again into about 28 different pieces using 7 languages, and one of the applications was written in Clojure, which no one in the company understood except one person who left the company. Distributed programming, okay? And that's what happens. Now, this is actually an application flow map that's been taken from a tool called AppDynamics, okay? It's an APM style tool. I'm not saying that you should go and use this tool. What it does is it shows the interaction between the services, between the web tier and the databases, and so on and so forth. It's there to show purely there are many different paths through your system, and life has become difficult. Now, because we have distributed programming or distributed systems, we have extreme difficulty in testing. Can anybody put their hand up and tell me that they honestly have every piece of their system running on their local machine? Exactly. It's impossible. There are so many different pieces of our systems these days. And not only that, new pieces are being created in the company all the time, and because teams are so disconnected, you may not even know it exists. Okay? So this is a joke, of course. Please don't just test all your stuff in production. You would have to be very, very confident that that's actually happening. But the point of this is that it's impossible to test every scenario that we want to test on our local development machines. There has to be a testing pyramid. You have to do different levels of testing on different pieces of infrastructure. So we would have local machine testing, we'd have our CI server testing, we'd have our infrastructure testing, we'd have then production tests, which test another different layer. Everything has to work together. How do we build a complex distributed system as well as being able to scale? Okay, now what I mean by this is that we are adding more pieces to our infrastructure all the time in our companies. There are very few companies out there that have one small system that they maintain and keep a hold of, whereas most companies are trying to compete in the market and they're adding new pieces, new features, and wanting to keep everything moving. How do we do that in a way that ensures us that we can add to it and scale our teams, but still stay relevant to what we're doing? Now, the best quote in this I've taken, and I use this all the time. I really do. Netflix actually said the best way to avoid failure is to fail constantly. Okay. Now, I'm not suggesting that Netflix are always having problems in production. Please don't take that to be the case. What they actually mean here is that they expect failure. And because they expect failure, they're able to recover from failure much faster. Okay. So I'm going to introduce something called chaos engineering. Anyone heard of chaos engineering? A few people, quite a few people. Chaos engineering has become a lot more popular than it has been over the past few years. It used to be select places doing it. Now it's becoming much more widespread thanks to like the DevOps movement and so on and so forth. So chaos engineering is like, it's about experiment on your system, but knowing what you're experimenting on so that you can prove that your system will withstand problems. Okay, there's a website, you can go and have a look at it. The best people who test your system are not your QAs, are not your developers, are not your managers, users. I have found to be the best people who test my systems, okay? Because no matter how confident I am that I have covered every single piece of my system with some level of testing, a user will always find a bug. Okay, they will always find something because as developers or QA or system engineers, we know the happy path through the system. And what we're guilty of as well is we can rationalize when we find a piece of behavior that doesn't work quite the way we want it to. So like, for example, we go to one of our sites, we initiate a message or initiate a transaction and it doesn't quite work, and we'll be like, oh, that could be because like the messaging server in the background is overloaded, or it could be because our database is like a latency problem or something like that. We try and rationalize why there is an error. When it's a user, they don't. They'll just go, this is broken. And that's what a lot of bug reports say, this is broken. So you can go and have a look at it. Now, the way to think about this is that all systems have weaknesses. Okay? Does anybody believe their system doesn't have a weakness? Now, I gave this talk at a conference a few months back, and somebody actually was like, ours doesn't. And my response was, there's one of two things that happened here. Either A, you're the best coder that ever lived, and I am hiring for my team. Please come and see me at the end. Or B, you don't have any way of seeing what's going on in production. So I asked about the metrics and about the observability of the system, and they were like, we have Nagios. I'm not saying Nagios is bad. Nagios is one view through your system, okay? It's not everything. Okay, of course you can configure it to do a lot more, but this person wasn't like using a complicated or, a complex sort of pattern of observability to see like database transactions or metrics or traces through the system, and they just didn't know what was going on in their system. And it highlighted an area. Before you do anything, before you run any of the things that I'm talking to you about today, please be confident that you understand what is going on in your system. Please, if you take nothing else away and you want to sleep for the rest of the session, please spend some time in observability of your system. There are lots of companies you can pay small amounts and they will actually help you do that. It's well worth the money. So let's just take that a system has many layers. Hands up, full stack engineers? Yeah. Do you work all 5 of the layers? It's a joke. Full stack engineering is one of those things that people like. It's like the new agile or the new DevOps or whatever. Different people's perceptions have different meanings of connotations of what layers they work on. So I'm not picking on you, don't worry. Okay, but realistically, your system has many more layers than this. Okay, you may be on a cloud and you may not care about hardware or network. So you have a combination of different things. Okay. So realistically, sometimes we have like an application layer, a caching layer, database layer, networking layer, hardware, and any of these systems can fail. Any. I have been in many scenarios where I've been woken up in the middle of the night with a page. Okay, and I'm sure some of you people in the audience have as well, where you just get a page that says the application is down. Okay, no more information on that. You don't know if it's the application or the caching layer or the database layer or if it's a networking problem or if you have a host failure. Because it can happen at any of these. In fact, and I'll be honest with you, about 45 minutes before my talk started, one of the demos that I'm actually going to show in our tracing layer went down because the database layer went down. Cassandra went dead. And I'm like, Cassandra says it's up. Because the job was saying it was up, but it was that the key space had fallen out and the key space needed reinitiated so that it had to be brought back online. But because we have got these layers, we can start to increase our reliability on these areas by testing in advance that failure happens. Okay, so like, let's start at the bottom. Just don't, okay? Don't just go to your data center or your hardware rack or your server rack and switch the power off. Like, you'll probably be fired. But of course, that is a way of testing chaos. What would happen if somebody switched off your servers, okay? Network layer, maybe a little less of a disaster because, you know, if somebody unplugs a cable, they can plug it back in very fast, but a boot up time of a hardware rack takes a lot longer. Okay, database layer, just destroy one of your database instances if you're comfortable in doing so. Cache layer, invalidate your cache, or use Redis, and it'll validate itself for you. Sorry, Redis people. And lastly, application layer. Okay, so application layer interacts with any of these. And it's the easiest layer in which to start your testing. Okay, and we'll talk about some things through. Now, there are 4 principles of chaos engineering, okay, or chaos testing, or resilience engineering, whatever you want to call it. Okay, because people will have their own terms for it within the next 6 months, 12 months, 18 months, whatever. It'll become one of those things. Number 1, you have to define the steady state of your application. If you can't specify, number 1, that your application is steady and that you have metrics and monitoring in order to do so, stop. Just stop there and then. Spend some time on that, then you can come back and move on. Okay. Number 2, you can actually create a hypothesis that when a specific event happens, that the state will continue, that state that you want it to continue. And I'll give you a real example about this in a second. Number 3, pretend to be a user and do something within that environment. And number 4, you actually measure and try and disprove that that hypothesis actually happened. Okay. Now let's think of a real life example that makes it really easy to think of. Okay. Number 1, my steady state is that when my application can connect to my database or my cache, then the application will be returning 200 requests and it will be working as expected for users. Great, steady state. I can see that in my metrics and monitoring. I can see that in my health checks and so on. Number 2, I hypothesize that when the database goes offline, okay, i.e. when the application cannot connect to the database, that my application will not be able to function correctly. Makes kind of sense, right? Very simple. If you take your database off and you're making database queries, your app won't work. Number 3, now, 3 is where it can start to get a little bit more interesting, and you can do this in many, many, many different formats, okay? So what we can actually do here, you don't really want to take your database offline. Okay, that would be a bit drastic and it may cause real problems. So what you could do is if you're in AWS or Azure or Google, for example, you could introduce a security group rule that blocks the database port so that nothing can connect to it. And then that's a very quick test in place that you can reverse very easily with automation. And then you can test what happens when that block goes in place. If you have a physical data center, you can use like IP tables, you can use all sorts of rules locally for this. Okay, and number 4, run the experiment and actually see what happens. Now after you run it, and you see that your application goes offline, you can either go, well done, Or you can go, right, how can we now stop our servers or stop our users being affected by a database outage? Wouldn't it be really nice if our website didn't start throwing 503s? Wouldn't it be really good if the application degraded gracefully so that the user wasn't spoiled and that they were given a nice message in order to do it? So you would implement the features in order to do that, and you would run the tests again and make sure it happens. So you're continually running tests going through it, and so on and so forth. I said you cannot do this without monitoring. You really cannot do this without monitoring. And monitoring, to me, there are 4 different types of monitoring that you can do. Okay, you can do your system availability and your system metrics. It's what most people do. Okay, it's you get alerted when you get a 404 or a 503, and you can check that the CPU of one of your database servers hasn't gone to 90% or so on and so forth. Okay, great. What I will say about those is you really need context. If you're using those as a measure of your system health, you must have context around those. So for example, it's not of any use whatsoever if you get paged in the middle of the night that tells you your database has a full disk. Okay, because you have to ask yourselves the questions, how long a period did it fill up in? What was the rate of change of disk usage? And you need this type of information, because if it's been growing for 6 weeks and 6 weeks and 6 weeks and keep going and growing and growing and no one's done anything about it, then eventually it was going to fall off a hill. Now, if it has grown, that the database has gone from 10% of disk usage to 90% disk usage in the last 4 hours, that kind of indicates that there's a problem in your system or your database. And that's the type of information you require when you can really start to dig into what's going on in that area. Now we leave the land in which most traditional operations teams work in, and we go to user metrics. Does anybody measure user metrics within their system? What I mean here is, if you have a call center, which would be a good example, do you realistically know the number of calls you get a day relating to errors within your system? Okay, and on a normal day, we can sort of average it out and work out what's going on. And then we can understand that if all of a sudden that increases by a huge amount, there's maybe a problem in our system. Okay, and like really, this can be measured, and like people are going, yeah, it's quite a good idea. This is simple stuff, and most people do it, but you don't have the visibility within your company between the customer services team and the operations team, for example. So it's all about creating that communication flow. And number 4, which is the most important for me, and it's something we all do very badly in this industry, not all, I take that back, mostly do very badly in this industry, is we need service-specific metrics. So on a registration service or a login service, how many users a day log in? Or how many new users a day do we get registering within their system? Like, let's think of Netflix. I am almost certain that Netflix will know the average number of users a day on their application. And they will be able to use that metric, that if that drops drastically, there's possibly a problem within their system. You can learn so much about monitoring in a book called The Art of Monitoring by James Turnbull. And this is one of James's many books that he's written, and he's a wonderful, wonderful author. If you're interested in Docker or Packer or any of these technologies, James has written a book on it. Okay, he's brilliant. He's really, really great. Go and have a look at it, and you'll learn. It'll enlighten you to like the second level of monitoring within your system. So now we have established that we need monitoring. Okay, once we have it, we have to see what's going on. And then we go back to this thing called chaos engineering. And where did it come from? Okay, a little company, as I said, called Netflix in 2014, wrote a blog post that actually introduced chaos engineering. And they said that back in between 2008 and 2010, they had started doing this work in preparation for their movement to AWS. Now, they needed to test when they moved away from their own physical data centers and their own hardware. Now, they still have some today. They're not 100% cloud, because some of the things, like you listen to some of the talks these days, that they still say they're in the progress of moving because it's such a huge system. But when you were moving from a physical system to a cloud system, as Seth said in the last talk, it may not be your hardware, but it's actually running on hardware, on someone's hardware. So you need to test how your system reacts if they have a problem. There are many examples of cloud failures in the past few years. There really are. There was one about 2 months ago from Azure where a thunderstorm in US South Central, I think it was South Central if I remember the data center correctly, took out most of Azure, because the replication times between them had gone down. There have been problems in Amazon where if US East 1 goes down, that basically takes down most of Amazon, because that's their primary data center, their global data center that runs IAM. And of course, if you lose IAM, you've lost basically most of your Amazon system. So Netflix were like, hey, we need to test this stuff. We really need to test this stuff. And they introduced a set of tools. Now, some of these names are pretty famous, right? I'm pretty positive at least 1 or 2 people will know the word Chaos Monkey. Okay, it's like a word that people throw on like job applications or job requirements. Must be able to like understand tools like Chaos Monkey or so on and so forth. Okay, but there are different levels within this. Okay, they created what's called a simian army, and simian army started originally with Chaos Monkey. And Chaos Monkey, I'm going to talk briefly. This is very Amazon specific right now. Very Amazon specific. Amazon is divided into regions. Within a region, there are a number of availability zones which relate to Amazon data centers. Not one-to-one, but they have a relation to data centers. And then you would run applications across a number of availability zones to give you high availability of your system. Okay? In a nutshell, TLDR. Chaos Monkey was the tool originally written to introduce chaos at an instance level only. Okay, what would happen if this application server went down? Okay. Then they created Chaos Gorilla, and Chaos Gorilla was introduced in order to test at the availability zone level. What would happen if US East 1A disappeared? Would my system be still highly available for the users because we're load balanced across B and C in order to work as expected? And lastly, they introduced Chaos Kong. Chaos Kong's the big one at the back. And that was to simulate what would happen if an entire region went down. And it has happened. Regions have gone down. And what they could see is that when a region went down, they needed to test their disaster recovery, their failover procedures very quickly, and run their scripts and bring everything up in another data center. Anyone work for a startup in here? Okay, so I worked for a startup about 2 years ago, and I was given the opportunity to like go in as a blank slate, and there's a development team, and of course as a startup we didn't have a sales team, which was stupid. So I went in and I was given this like, we need to develop this infrastructure, okay, and we need to be able to fail over from one database or one availability zone to the other, and I was like, okay, and we used a tool called Terraform. After that I went to work on the Terraform tool, so I built all of these scripts and all of these systems, and I actually was able to prove just before I left the company that if they ran Terraform, they could actually fail over from US West 1 to US West 2 in 6 minutes, including bringing up the databases, which was pretty awesome, right? Of course, the startup went bust, but it's just the way it works in startups. But it gave me the understanding that testing this stuff was really, really necessary, really necessary. But who practices it? Okay. Now, Uber, Dropbox, Google, Amazon, to name a few. Netflix, of course, as I've already mentioned. Okay. It's becoming more and more widespread. Uber did it because their master log replication from their applications to S3 actually failed because of an S3 outage, and their database, their primary database, filled up and filled up and filled up and filled up, and eventually dropped over. So Dropbox did it because of a problem of replication between master and replicas in their database server, and they brought the Dropbox server down. Google and Amazon have been doing this for years before people even knew it was a concept, okay? Because as is everything in IT, we're very good at renaming the concept and making it relevant again 20 years later. And there are amazing people who have been doing this in this industry for a long time, okay? Like Google actually called this disaster recovery testing. Think about it, it's disaster recovery testing, right? You're testing that you can recover after a disaster, okay? But you must look at any major system on the internet these days, okay? LinkedIn, so on and so forth. If they have a major outage that has caused a bit of a public stirring for them, they will start to investigate these ways of working so that they stop that happening. They really will. System failure happens. It's just a matter of time until something happens within your application or your system. It really is. I know that there's one, as soon as I finish this presentation, I have to deal with. And it's a Sunday. Luckily, it's a test server, but still I want the test server to be online for the rest of the developers starting on Monday morning. Now, since I first gave this talk, like 2 years ago, there's a lot of new tools that have been created. Okay, both in the open space world and in the paid for world. And a tool called Chaos Toolkit is one of them. Okay, it's a Python-based tool where, and I'll show you a demo of it actually. Da-da. So what it's doing right now, it's basically saying, let's run an experiment to terminate a DB instance. It's validating that the syntax is correct. So it's terminating the database. We know that the hypothesis is there, is the application must be alive and healthy after the database goes down. Database is on its way down. It waits for 20 seconds to simulate that it's actually gone down. And when it's finished, it will run the check to make sure that the hypothesis works as expected. As you can see, it's just a CLI tool. You just pump JSON into it. You can go and have a look on the website and have a look and see what goes on. And you can run this test as many times as you want, and you can be confident with it and so on. Now, this is just one of many, many, many ways of running it. There are drivers for Amazon, there's drivers for Kubernetes, which is a huge thing right now people are moving to. So please test your Kubernetes installations. Okay, Google Cloud, there's ones for Cloud Foundry, there's new ones for Azure coming up. So you can pretty much go and you can write your own sort of Python scripts that'll do this based on this framework. It's really simple, really easy. Now, there are other tools as well. There is another company that have just really become very popular called Gremlin. Okay, Gremlin are one of these companies that they're really starting to hire people who have a lot of talent in this area. Okay, like in the chaos engineering area. So one of the people who I follow a lot and really listen to a lot about what's going on in chaos engineering is Tammy Butto, who worked at Dropbox, and she now works, she's one of the principal SREs at Gremlin, and the source of information that comes out of the Gremlin team right now is wonderful, and it's really sort of ramped up this area. It's a paid for app, of course, so if your company wants to like spend some money in this area, as I said, you can go and do it, and you can actually mean that you don't have to like implement everything yourself. And now I thought I would run some demos. Okay, let's try this and see. So right now it's very AWS specific, and I am going to run Chaos Monkey live, and we'll see what happens. Okay, we'll run a number of experiments and see what goes on. Firstly, I am not running this on my production system. I'm sorry, I'm building something for Samsung right now that Samsung would not be happy about if I ran this. So I have brought up, let me show you what I have brought up. I am simulating that we have an application cluster of 20 nodes, okay? This is just something I launched about 3 p.m., like 1 hour and a half ago. I launched an autoscaling group with 20 nodes in it. Okay, so, but one thing I will show you is I profess that you need system monitoring throughout. Okay, and I will show you how the monitoring of our not production server works right now. So firstly, we use Jaeger for traces for everything. Okay, and we see all the requests that come in via Jaeger. If I run the traces again, and we can see the system outliers. So we know the normal progression. In fact, if I make this 1,500, you'll see a much more sort of normal distribution of the traces, and you'll see some of the outliers across the top. Okay, so we can see that right now in our test system that we have something that takes 2 seconds. That's actually a VM creation, by the way. That's not anything that the user sees. It's a request that happens in the background because we run a pub sub messaging pattern, and we can actually spin up a machine within the 2 seconds. So everything is there, and everything is actually tagged so that we can actually see what transaction it relates to, and we can see all the processes that happen across a transaction. Okay, really important. This is a free tool. Okay, this is really free, and the code in order to actually run this, not the application itself, you can find that there's like already runbooks in place that will allow people to do it. I'm just going to show you how we actually send something in there. So if I go to region, so you get a tracer, which starts an open tracing client. You generate a span, which is everything is inside a tracing client. It's called a span. You defer the finish. This is go, so it doesn't matter. And then in the background, that's flushing through in a go routine. So it's minimal overhead, absolutely minimal overhead. But as you can see, it's a huge amount of benefit to what we're doing. Next thing we do, we ship logs. We use Humio right now because we're building something in test. And we ship logs for every single piece of what we're trying to do. This is live streaming of our logs across the last 5 minutes in our test server. And you can see it's churning. And look, this is 1630. 1630 here, you can actually see that those are real live log messages, and we can see that, look, we're creating transactions for different pieces. We're actually generating our resource our resource IDs, okay, and everything is going through. And lastly, we graph everything. We use Sarconis. Sarconis is one of many monitoring tools that you can get out there. I love it. I think it's investigate it if you don't have one. And we can start to see, because everything goes in, the separation of data ingestion from the display is what makes Sarconis very special for me, just because of the fact that the metrics go in as raw metrics, and then if you display them, you can perform changes to the metrics, but the base under the hood is still intact. Okay, and we can start to see the normal distribution of what happens across any server and across any of our different transaction layers. Okay, so just to show, we do practice what I'm trying to preach to you. So let's go back to what we were doing. So I have an instance called a chaos instance that is currently running. Anybody have any questions before I go on with the demo, by the way? Question? Good question. Why not Zipkin for tracing? Or circuit breaker pads? Right now we're building a platform with 2 people. Okay, so it's purely a manpower thing, or like a person thing. Okay, as we ramp the platform up and we start to build it out more and more, there's I think there's currently a backlog of about 50, 60 different pieces of the system that we're going to even more fine-grained implement in tracing and push different things through. Right now, Jaeger was so easy to get up and running. It's a Docker container. So, and it was purely that. Go for it. Yep. Absolutely. So it's a really good point. You can't just go and sorry. So the point John was making is that you can't just go and implement this within your system. Just they paraphrase what you're saying. You actually have to design this into your system using pieces of, like circuit breakers and so on and so forth. Correct? Yeah. So what I'm trying to tell you to do today is not just go and run Chaos Monkey in your system. Please don't take that, okay? Please don't assume that that's what I'm trying to show you. What I'm trying to show you is that when you have the pieces in place, you have the observability around your platform, then you can start to plan in a very controlled way experiments that will help you change the architecture and how you build your platform going forward. Okay, really, really, really important. Thank you for the good point, clarification. So we have Chaos Monkey running. And if I Chaos Monkey, I have an endpoint, which is an EC2 endpoint. And if I run, so this is a CLI tool, okay, that talks to Chaos Monkey that is actually exposed within a web server. Okay, don't just expose like this type of information across a web server, please. The guy who wrote the CLI tool actually said in his talk that he's given multiple talks on this, and you can go. He has this hidden behind HA proxy. He's so confident of the system, and they can actually like use a username and password in HA proxy, pushing it through, that they can run experiments from like he said from like a beach on his phone. Okay, so it's like the goal of like continuous delivery. You know, you can deploy from a beach type thing. So you can see that I ran some experiments today. And the last time I gave this talk, and it keeps a history of all the experiments you run, okay? Now, by the time this talk is posted, this auto-scaling group will no longer be in usage, so you cannot mess with my Amazon instance. As you can see, I changed it between talks, okay? And this application server will be brought down. And you can see that I'm running the different things, like burning CPU, network latency, shutting down instances, and so on and so forth. So I have in the tool, what we can do, the first thing we can do is just prove to you. So my experiment is, firstly, the hypothesis is that my system has 20 application instances. Okay, and I can search and I can say tag name application instance. And I can see I have 20 running application instances, okay? I am going to introduce a real-world event right now that will shut down one of my instances. And my hypothesis is that as this is an auto-scaling group in Amazon, and if you're in Azure, you would have a scale set, and if you're in Google, you'll have your a scaling manager, which will bring it all up for you. Different clouds have different mechanisms of doing this, but we will be able to see that in 60 seconds, Amazon will bring a new machine up in its place because that's their guarantees of availability. Auto-scaling group, sorry. So if I run it, and we'll actually say the instance it's going to close down ends in 9996, so we can go and have a look. It's this instance. If I refresh, it's currently shutting down. It's right at the bottom. And in 60 seconds time, a new one will come up in its place in order to replace it. Now, while this is happening, now we get to some of the interesting points. Okay, and I'll just let it run in the background and show you, and then I'll run another experiment. Actually, I'll run another experiment at the same time. You can do this and say, no. Run the shutdown instance 5 times at an interval of 60 seconds. Okay? And what that's going to do is every minute for the next 5 minutes, it's going to shut down a machine. And we'll just watch it and happen. Now, a couple of things to note here. This is planned chaos. I am running this now and forcing chaos into the system. Okay? Real chaos engineering happens at an undetermined time. Okay, I understand that, again, you have to plan this and you have to build your system for it. But normal day problems don't happen between 9 and 5. Okay, they happen at like 2 o'clock in the morning when you're sleeping or when you're on a plane. That happens to me a lot. And so it's important to understand that this is actually being forced in to show you what happens in a scenario that I'm trying to do. A real way of running Chaos Monkey, as an example, would be that you would run the probability engine. Okay, and if I SSH into the machine, again, this won't exist. Just note. Okay, and if I sudo cd simian army, and if I vim chaos.properties, we can start to say what pieces of chaos are enabled and what not. Firstly, probability 1, which means that any time an event happens, it will destroy something or change the characteristics of something. You can change this to 0, 6, and then like 6 times out of every 10 requests, it'll go through and so on and so forth. You can play with these as much as you want, okay? But the most important thing is that it happens at different times, okay? Because this is like a demon that runs in the background, and you don't want to know when it happens. But what you want to do is be alerted when something has happened. So like if you have a Slack room or email or something like that, you want this to post messages through for you. It's really important that you do that. Okay. Somebody asked me, I gave this talk in Australia last month, can we actually set this up to do chaos between 9 and 5? My response was, you certainly can. You absolutely can. But it's not going to give you the resiliency and the confidence in your system that you want, because you know it's going to happen within your workday. They were like, but isn't that a better thing to know? It's like, yeah, but how many problems do you have in your workday compared to how many happen out of hours? They were like, we have a lot more out of hours. It's like, so sometimes it's good to know the tests and good to know that your system can fail over, but it's also good not to have people around and online when these types of problems happen. Really, really something that's key. So if I go back and refresh, we can see, so firstly, it has brought new machines up in order to replace it, and the system is coming back to normal. Currently, we're on 4 machines shutting down, and it's just churning through in the background. So let's run another test. Let's hopefully see that this test is finished. Oh, it's still on number 3. It hasn't quite gone to number 4 yet. Any other questions while I'm waiting on this to happen? Question at the front. So what's the difference between running a kill -9 compared to like a shutdown instance command? So shutdown instance is using the Chaos Monkey API, which is written on top of Amazon specific APIs. Okay, and that is like shutdown instance or terminated instance is Amazon specific. But of course, if you had this run in your local data center and you had a local process that you wanted to kill -9 would work exactly the same for you. Exactly the same. So remember, this is running against a remote data center. From my machine against a remote data center. So a kill -9 won't work here for me.
Yeah, but I can use something like Ansible.
Absolutely. Ansible would work here as like a basic tool in order for you to like test in this area. Of course. Absolutely. So this way is forcing the shutdown. Like this is really forcing the shutdown. For what it's worth, the reason I didn't like suggest Ansible here is I don't use a configuration management tool. The stuff I build is immutable, and if it's destroyed, new ones come up in its place. So, of course, if that's what you use within your company, that would work as well. It would really work too. There was another question. Someone? Yeah. Oh. Let's come back to that, right? I'm going to shelve that question for a second. So the question was, it's an interesting point, is when should you start your chaos testing? And I promise, let me just wrap this demo and I'll come back and I'll talk about that. I really will. Okay. So we have 5 instances that are currently down right now. And I can say state, instance state running. So 17, so 3 have already been replaced, and there's 3 more due to come back up in its place. So Amazon is replacing these on my behalf, and I am unhappy that they're doing that. It's very basic check, very, very, very basic check. Now if we do something slightly different, I might not have time. This is usually a 1-hour talk, and I'm trying to fit this into 50 minutes. So we can burn the CPU. This is going to fail. Yeah, HTTP error. Sorry, I've just disabled the endpoint before. So we'll skip that one and come back. So the question was, when should you start chaos engineering? It's a loaded question. It's really a loaded question. For me, as John pointed out, I'm in a very lucky situation because I'm building a lot of greenfield applications, and therefore I can build this type of thought process into what I'm doing. Okay? If you are not in that scenario, I would start with the smallest tests possible. Okay, so for example, a great one would be, what would happen if I can't SSH into a server? So like if you have Ansible, for example, like this is just to show, like, grow confidence within the company, because emerging to a way of working like this will be a big, like, red flag to a CTO. They'll be like, whoa, this is dangerous. This is like introducing risk. How do we do this in a friendly way? So like, how I introduced this to a company I worked at before is they had Ansible. So Ansible was ran at a developer ran Ansible just whenever they wanted, and it shut off the SSH access to a server. Okay, and then 20 minutes later, there was a message in the chat room saying, "Is there a problem with like this server?" And everyone's like, "What do you mean?" They're like, "I can't SSH into it. Does that mean the server's up or down?" And the developer's like, so I shut that SSH access off 20 minutes ago to see if anybody actually could see that there was a problem with it, and they immediately switched it back on. So it wasn't to show that that's chaos, but it was to show that they had no observability into what was going on that server. Because if you have SSH access that's required and it goes down, you should probably get an alert on it. Question?
One of the best presentations I've ever seen is by Theo Schlossberg, the inventor of science. QCon London in 2016, where he talks about observability before you get to chaos. He's one of the smartest guys in our industry, and his presentation is incredible for that.
Absolutely. So the point John made was in 2016 at QCon London, there was a talk given on how you must get to observability before you practice any of this. And it's 100% true. Okay, this talk is not for you to go away and start destroying stuff tomorrow. Please don't do that, because I really do not want to be in trouble with any of your companies. Although, if you need me to come and fix some stuff, no, not really. You must get to a point of being able to think, if this happens, do I understand that it has happened within my company? Okay, that's where you start with chaos. Chaos has that big prerequisite, and if you don't have that prerequisite in place to have that pane of glass to look through your system, then it's almost impossible. So it's really important that that's where you start, and you can, within your own QA environment or your own test environment that doesn't impact any other people apart from within your team, just run random breakages or random failures and see if people notice, see if people are alerted. And if they're not, it means that something that they require is not monitored correctly. You put those places in check. You can do the same thing 2 weeks later. If they go straight away within 2 minutes, SSH is dropped on that server. Now you're in a situation that everyone understands what's going on within your platform. Make sense? And it's a really, really, really good point. Now, there's like lots of information here. The most important piece of information on this screen is the chaos community. Okay, there is a Slack channel that you can join, and there's a lot of information in there. There's people from all sorts of companies joining right now, and they're like, one of the main things that the DevOps movement helped me to understand was the best way of understanding and learning from something is by sharing your failure with others. Okay, it's like one of the huge parts of DevOps that people really forget. It's not just about you working in this bubble and like being able to spin up these servers and bring them down. It's really, really, really about sharing this information at events like this or within Slack or so on and so forth. So get in there if you're interested, okay, and ask questions. There's no such thing as a stupid question in chaos, because when a disaster happens, and it will happen, I promise you, it's like a ticking time bomb. You need to understand what to do. There was going to be a question right here.
Principle of house engineering is minimize blast radius, and does the tool of the Siemens Army or another house engineering framework maybe have a templates to describe a behavior where I can define minimize blast radius from my running experiment in production systems, you know.
So it's a really good
It's
point.
important,
One of the principles is what's been said here is to minimize the blast radius. Okay. Now, I told you I worked on Terraform. Before I worked on Terraform, I used to have one large Terraform file that ran my entire AWS region. It ran databases, it ran application servers, it ran my DNS, and so on and so forth. By starting to understand the principles of chaos, I split that up into each significant area, because if there was a problem, and unfortunately there are some problems when you use open source tools, okay, where a Terraform run dies in the background and it doesn't save its state file, you have all of these instances or all of these DNS entries that have been created, and then you're in this situation where you have to manually edit this Terraform state file, okay? So to minimize the blast radius, we said, right, applications are managed in one block. DNS managed in another block. Caching managed in another block. And that way you're only limiting the changes to specifically what you want to do, rather than potentially changing your database config if somebody changes like a security group name or something like that. So blast radius limitation is certainly an area, okay, really an area. And I have 33 seconds left. There was a conference on this. Like any good movement, there was a conference, okay? Now, again, this was more about sharing rather than like selling. And it happened in 28th of September. And funnily enough, John mentioned Adrian Cockcroft, who helped. He was one of the cornerstones of architecting of what Netflix is today. He was actually the keynote. Wonderful talk. All of the talks are available on YouTube, so you can go and you can download them and watch them. There's a great talk in there by Charity Majors on observability. Definitely, this is a lady who's amazing in that area. You should really understand what's going on and listen to some of her talks on it. You can find me around the conference. Okay, I'll hang around for the next couple of hours and you can ask me some questions. You'll get more funny answers about this type of stuff after I have a beer. And you'll get my real opinions rather than just here's my conference hat on. So thank you so much, and get in contact with me if you have any questions.